A black hole is a large amount of matter, squeezed into a tiny area, with an enormous gravitational pull for its size. Many black holes form from dying giant stars that collapse in on themselves. Visualize it this way. If the Earth became a black hole, which it couldn't, it would weigh the same as it does today, but its size would be smaller than a human eyeball. However, that eyeball would have the same gravitational pull, so the moon would keep orbiting around it. Not all scientists believe in black holes. But for those who do, the surprises just keep coming. Number 1. Our early ancestors may have seen the Milky Way's black hole. Around 2 million years ago, the supermassive black hole at the center of our galaxy burst into life with a radiant glow. At that time, man was just beginning to walk upright. Our ancestors would have seen a moon-sized light in the southern sky that looked like a bright fuzzball or smudge. The black hole light show would have lasted a few thousand years for our ancestors. According to anthropologist Chris Stringer, it was the beginning of the genus Homo. Stone toolmaking had already begun, but the brain was only beginning to enlarge. Number 2. More gluttonous than imagined. Until recently, scientists thought that the size of a black hole determined the top speed at which it could eat and produce light, the Eddington limit. Then they discovered P13, a black hole in the galaxy NGC 7793, which rotates around a supergiant star while cannibalizing it. P13 is believed to be 15 times smaller than our Sun, yet 1,000,000 times brighter. It has the ability to devour its companion star in less than 1,000,000 years, which is fast in cosmic time. Like the M82 pulsar, P13 is an ultraluminous X-ray source that not only violates the Eddington limit, it knocks it out of the galaxy. Astronomers now realize that there may not be a strict limit on how much a black hole can eat. Number 3. Black holes may prevent star formation. In mature galaxies, researchers discovered that massive black holes can stop the development of baby stars by spewing out particles that emit radio waves. Traveling near the speed of light, these heated jets act like off switches to stop hot gas in the galaxy from cooling and condensing into new stars. Number 4. The center of a galactic murder mystery. Some astronomers believe a murder mystery in space is turning pulsars into small black holes. It's called the missing pulsar problem. 2 researchers have proposed that a pulsar's gravity may attract certain particles of dark matter, causing the dark matter to swell the pulsar to such a large size that it collapses into a black hole. The pulsar becomes so big that it punches a hole through the fabric of space-time and disappears. Dark matter can't collect as densely or as quickly at the center of regular stars, said researcher Joseph Bramonti. But in pulsars, the dark matter would collect into about a 2-meter 7 feet ball. Then, that ball collapses into a black hole, and it sucks up the pulsar. There is a greater concentration of dark matter at the galactic core, which may explain why pulsars are missing only in the center of our Milky Way. Number 5. Supermassive black holes may be more numerous than we thought. Black holes come in a variety of sizes, from primordial, as small as 1 atom, to supermassive. There may even be rare extra-large size, called ultramassive. At one time, only larger galaxies were believed to contain massive black holes. But in early 2014, astronomers revealed that over 100 small dwarf galaxies appear to have massive black holes at their centers. Based on some findings, some astronomers believe that many ultra-compact dwarf galaxies may be the remains of larger galaxies that were torn apart when they collided with other galaxies. So, there may be as many supermassive black holes in the centers of ultra-compact dwarf galaxies as there are in larger galaxies. Number 6. The Eye of Sauron shows black holes way more. Astronomers now think that supermassive black holes at the centers of galaxies have 40% more mass than originally believed. This may help to explain why the Eddington limit of brightness isn't working with some current calculations of mass. Researchers used a land surveying technique to measure the distance to the NGC 4151 galaxy, whose active core is called the Eye of Sauron, because it looks like its namesake from the Lord of the Rings movies. Scientists decided to use the twin Keck telescopes in Hawaii and simpler mathematics to get a result with almost 90% accuracy. Number 7. Gobbling mass like a baby Pacman. Scientists have puzzled over how an early black hole can begin life at an estimated 10 solar masses, then quickly grow to more than 1 billion solar masses shortly after the Big Bang. Under normal conditions, gas pulled toward a black hole spirals down to form an accretion disk. Some gas trickles inside, but several processes usually slow the growth of a black hole. Researchers believe the early universe contained cold gas streams that were much more dense than exist today. A young black hole would have moved quickly, continually changing direction like a gobbling baby Pacman, as nearby baby stars knocked it around. These fast directional changes may have let the black hole eat material directly from these denser gas streams so quickly that the slow spiral never happened. As the black hole grew, it ate even faster. Number 8. Not every cosmic powerhouse is a black hole. For decades, many scientists believed that extremely bright X-ray sources known as ultraluminous X-ray sources had to be caused by black holes eating stars or other matter. When the immense gravity of a black hole attracts the gas of a nearby star, that gas spirals down to form an accretion disk around the black hole. Like water circling before it goes down the drain, the gas accelerates greatly, heating to extremely high temperatures that release bright X-ray light in every direction. The larger the feeding black hole, the more it consumes, and the brighter the light. Nearby galaxy M82, astronomers accidentally discovered a Hawk source that pulsed, emitting a bright X-ray beam that swept past Earth every 1.37 seconds, like a lighthouse beacon. The problem is, black holes don't pulse. Pulsars pulse. Astronomers are now re-examining other Hawk sources to see if they pulse. They can no longer assume that every Hawk source, or cosmic powerhouse, is a black hole. Number 9. Explaining how bumblebees fly. Until recently, most gravitational researchers believed that space-time couldn't be turbulent. But 3 scientists turned that belief on its head when they decided to analyze whether gravity could behave like a fluid. Under the right conditions, fluids are turbulent. Like cream stirred into your coffee, they may swirl and eddy instead of moving smoothly. The results were surprising, even to them. Over the past few years, we have gone from a serious doubt about whether gravity can ever go turbulent to pretty high confidence that it can, said researcher Louise Lenner. New detectors may soon have the ability to detect gravitational waves, ripples in space-time, that behave like waves in the ocean when a boat sails through it. In space, gravitational fluid may ripple from huge cosmic events such as two black holes colliding. But these findings may also help us to understand turbulence here on Earth, including the physics of hurricanes, wind shear with airplanes, and the seemingly impossible flight of the bumblebee. Number 10. Our universe may have spun from a 4D black hole. One big problem with the Big Bang Theory is that our scientifically predictable universe originates from a singularity, an infinitely dense point, that doesn't play by the same rules of physics. Physicists don't understand singularities. They can't explain what sparked the Big Bang. Some physicists believe it's unlikely that such a chaotic beginning would produce a universe with a largely uniform temperature. In our universe, a 3D black hole has a 2D event horizon, the boundary around the mouth of the black hole, that represents the point of no return for anything that falls inside and gets trapped by gravity. In a universe with 4 spatial dimensions, a 4D black hole would have a 3D event horizon. If we consider their theory absurd, they argue that thought simply because we don't understand the 4D universe. Our thinking is limited by a 3D world that may represent only the tip of reality,